In this video, we're going to be looking at angles and how they interact with each other. Or in other words, we're going to be looking at angle relationships. The first relationship we're going to look at are adjacent angles. Adjacent angles are two angles that lie on the same plane and have a common vertex and a common side, but don't have any common interior points. In the little examples that I've got below here, we're looking at angles 1 and angle 2 are adjacent angles in the first two ones. So angle 1 is here. Angle 2 is here. And so we can see that they have a common vertex right here and a common side right here, but they don't have any other points on the interior of either one of those angles. All right. In the second one here, the same thing. Angle 1 is right there, and it's an obtuse angle. Angle 2 is right here, and it's an acute angle. And so you can see here that it doesn't really matter on the classification of the angles at all, or the orientation of the angles, as long as they have a common vertex right here and a common side right here. Okay, and that they don't have any points that are on the interior of either one of them that are shared. Okay. On the right hand side, these two over here are non-adjacent angles, and I wanted to give you an example of what those look like. Okay, it says angle 3, that's this angle right here. Angle 3 and angle ABC are non-adjacent. Well, the reason that they're non-adjacent is although they have a common vertex right here at B, all right, and they have a common side right here, BC, they do have common interior points because this line right here, or line segment right here, the line right there is on the interior of ABC, but it's also part of angle 3. So that's why that's why they are not adjacent, because they have common points that are on the interior of ABC. All right. On the far right one here, we have angle 3 is here. Angle ABC is here. And it's pretty obvious to see that the reason that this is non-adjacent is because we do not have a common vertex. Go ahead and pause this video and copy down this definition for adjacent angles. All right, the next definition we're going to talk about, or the next relationship we're going to talk about, are linear pairs. Actually, they're not. Yes, they are. We're going to talk about linear pairs. Linear pair, obviously you know a pair is two adjacent angles. Okay, so linear pair, linear, you may suspect, talks about a line. So a linear pair are two adjacent angles whose non-common sides are opposite rays. And just as a side note, the linear pairs, the angles in a linear pair are supplementary. And we'll talk a little bit later what it means for angles to be supplementary. You may already know, but we're going to discuss that a little bit later. All right, so in this case, two adjacent angles. We have angle 1 right here, and we have angle 2 right here that are adjacent. In other words, they have a common vertex right here, and they share this side. They share this common side right here. Okay. The thing that makes it a linear pair is that the non-common sides are opposite rays. So the sides that they don't share go in opposite directions. And so that would be this blue line, this blue baseline, and the orange baseline go in opposite directions. And so that's what makes it a linear pair. And you see that it forms a straight line. Right? So that's the key for a linear pair, is that the two lines, or the two sides that are not the common side, will join together and form a straight line. All right. Over on the right hand side here, we have angle ADB, okay, and angle BDC, okay. Those are not a linear pair. All right. Now, they are adjacent angles, okay, because they do share a common side, or a common vertex and a common side. So they're adjacent angles, but you see that the side AD and the side CD, or the blue side and the orange side, don't form a straight line. They actually form another angle. All right, so that's why they're not a linear pair. Vertical angles. Oh, go ahead and pause this video and write down your definition for linear pair. Vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. And one of the key properties of vertical angles are that vertical angles are congruent, which means that they have the same measure. The key part of identifying vertical angles is that it's formed by two intersecting lines. In other words, we have this line here, and we have this line here that cross. And when they cross, they're going to form four angles: 1, 2, 3, and 4, right here. 1, 2, 3, and 4. Well, the angles that are across from each other are what we call the vertical angles. So in this case, angles 1 and 3, angles 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. The key part of this is that the vertical angles are formed by two straight lines that cross. All right. So on the right hand side here, you can see it's pretty obvious that there are angles that are across from each other, but they're not formed by two straight lines. AEC is a straight line, but DEF is not a straight line. So DEC and AEB are not vertical angles, because they're not formed by a straight line. And also along the other side, AED and BEC are not vertical angles because of the same reason. If this is especially useful if we're talking about, if we're looking at a figure that has multiple angles that are across from each other, to make sure that you look at what are the angles that are formed by straight lines that cross, like in this example right here. So the first thing it asks are, what are two vertical angles? Well, when we look at this, vertical angles, remember, are formed by two straight lines. Well, this is a straight line that goes up through here. The other straight line is WVZ. Okay, so one of the first vertical angles that we're going to talk about are WVU and YVZ. All right, so that's WVU and YVZ. The other vertical angle, that we're talking about is UVZ and WVY. Right? You may say, what about that line VX? Well, because it's not an intersecting line, it doesn't play a factor at all in identifying vertical angles. So that second set of vertical angles is WVY and UVZ. The next one says, what are two adjacent angles? Well, remember, adjacent angles are angles that share a common vertex and a common side. So there are several adjacent angles. There's several pairs of adjacent angles. All right. Let me go back here to the vertical angles. The vertical angles, in most of the time in your classwork that you're going to be working on, you only have to name one of these pairs. So you only have to name like WVU and YVZ, and you would write it like I wrote it here. Or you could say WVY and UVZ. All right. You do not have to write both of them. I usually only ask you to write one pair of vertical angles, but you do have to write both angles. All right, same thing goes with the two vertical angles and naming a linear pair. Okay, so even though there are a lot more than two adjacent angles, you're only going to need to write down two angles that are adjacent. Well, adjacent angles, so we're going to say that the first set of adjacent angles are UVW, and then we're going to look at what's an angle that's adjacent to that. Well, we can say UVZ is adjacent to that. All right, so you can say UVW and UVZ are vertical or adjacent angles. Okay, and then as we move on around the figure, we can see that the next set of adjacent angles, because we went from here, we used this angle and this angle. So now let's use this angle and this angle. So we would have UVZ and we would have ZVY. All right. So you have UVZ and ZVY. continuing that pattern of going around the figure, we can say YVX and ZVY. All right. So we can say, let me do a different color. Let me go ZVY, the blue one. Okay. And ZVY, the blue one, and then YVX, the orange one. Okay. So we have ZVY and then YVX. All right. And then the last one that we're going to need to look at is the YVX, the orange one. All right. And the XVW. All right. YVX. YVX, the light brown one, and then XVW, the dark brown. Okay. All right. So those are the four sets of vertical angles. You have this one and this one. 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 All right. Now, the next thing that we're going to talk about are linear pairs. Remember, linear pairs form a straight line. Okay, so along with that, we're going to just look at the straight lines. In other words, we're going to look at this straight line UVY, and we're going to look at the straight line WVZ. So when we're looking at the different angles that make up the blue line and the orange line, you can see that we have several choices. All right, we can have the angle UVW and an angle WVY. Okay, so UVW and WVY. That's one of the linear pairs. All right. We can have UVX and XVY. Oops, not WX. XVY. You can have angle UVZ and ZVY. And those are the three combinations of angles that make up the blue line UVY. All right. Then we have the orange line, WVZ. And there are also 3 combinations for that line as well. In other words, you can have, oops, let me change colors. You can have UVW and UVZ. And UVZ. You can have that would be on the bottom part of that. Okay. You can have, if you go to the upper part, once again we're talking about the different angle combinations that form WVZ. All right. So we could have WVX and XVZ. XVZ. And then, or we can have WVY and YVZ. And so you can see here within this particular figure that there are 6 different linear pairs. So in your classwork, all you're going to need to do is name one of the linear pairs. And a linear pair is going to have 2 angles to it. All right. All right. So as I had said before, we're going to talk about complementary and supplementary angles. All right. So when we're looking at this, complementary angles are 2 angles whose measures add up to 30 degrees. So I have a 60-degree angle, I have a 30-degree angle. If I combine these 2 together, I should end up with a right angle that adds up to 90 degrees, and 60 plus 30 is equal to 90 degrees. Right? Along the same lines, if I have supplementary angles, I have 2 angles that add up to 180 degrees. If I have a 30-degree angle and a 150-degree angle and I combine them, I end up with 180 degrees, which forms a straight line. Now, we can use that to solve problems that use complementary and supplementary angles. So this particular problem says find the measure of 2 complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. Complementary, remember, according to the definition, complementary talks about 90 degrees. 90 degrees. So we have 2 angles that we know are going to add up to 90 degrees. So angle 1 plus angle 2 are going to add up to 90 degrees. And then we're going to look at how those 2 angles relate to each other. Well, we have a smaller angle and a larger angle. So we're going to say angle 1 is our smaller angle. I'm just going to use the letter S, or the variable S. That looks like a 5. I'm going to use the variable S to signify smaller. Okay, I can't draw an S, so I'm just going to type in an S. All right, so that's the smaller S. All right, so I'm going to say the smaller angle plus the larger angle is going to equal up to 90 degrees. Well, how do we know what the larger angle is? The larger angle is 12 more than twice the smaller angle. Okay, 12 more than means adding. Okay, so we know that we're going to add what? What are we going to add? 12 to twice the measure of the small. So that would be twice the small angle, plus 12. And this is the larger angle right here inside the parentheses. This is this is one of the angles, the expression for one of the angles, okay, is equal to 90. Okay, and then we just go ahead and use our algebra skills and we solve this equation. And to do that, we're going to combine our like terms. Okay, S plus 2S is 3S. I'm going to try the S again. 3S plus 12 is equal to 90. All right. Solve it. Draw a line down through the equal sign. We're going to subtract 12 minus 12 minus 12. Okay. The 12s cancel out here. Okay. 90 minus 12 is 78. And so we have 3S is equal to 78. We're going to divide by 3. And we can see that 78 divided by 3 is 26. So the measure of our small angle is 26. Okay? And then to find the measure of the larger angle, because of the fact that we know that they have to add up to 90, we can just say 90 minus 26. Okay? Use your calculator. 90 minus 26 is equal to 64. if you want to double check that, we can plug the 26. We can plug the smaller angle into our little expression here. We would end up with, which is another alternative, 2 times 26 plus 12. And we need to just verify that that's actually 64. 2 times 26 is 52. This is actually a 5. 52 plus 12. And 52 plus 12 is 64. Okay, so that's how you do the problems using complementary and supplementary angles. If it would say the measure of 2 supplementary angles, obviously instead of having a 90, we would have 180. All right. The last thing we're going to talk about are perpendicular lines. Perpendicular lines are lines or segments or rays that cross at a right angle. And as you already know, the measure of a right angle is 90 degrees. So if 2 lines or any combination of line segments or rays cross at a right angle or at 90 degrees, they're called perpendicular lines. And if lines are perpendicular, they're symbolized by this icon right here that looks like an upside down T. Okay? So if you see that icon, you know that those lines are perpendicular. All right? We also know that perpendicular lines intersect to form 4 right angles. Remember back a few minutes ago when we were talking about the vertical angles, I said if 2 straight lines cross, they form 4 angles. Well, this is even a more special case in that they form 4 right angles. They form angles 1, angle 2, angle 3, and angle 4. And every single one of those angles are right angles or are 90 degrees. Perpendicular lines intersect to form 4 congruent adjacent angles. So another property is that every one of these angles that are side by side are going to be adjacent and they're going to be congruent, obviously because they're all 90 degrees. And as I had sort of alluded to in the definition up on top, that segments and rays can also be perpendicular to lines or other line segments and rays. And this little square here that's in the corner, that's your right angle symbol, and that's what indicates that the lines are perpendicular. So when we're solving equations that even though the lines look like they might cross at 90 degrees, unless it has that little square in there or that right angle symbol, or unless you're told that they're perpendicular, you cannot assume that they are. They may be a measure that is very, very close to 90 degrees, but unless it's exactly 90 degrees, they're not perpendicular. So be careful when you're solving equations that just because they look like, or with figures, just because they look like they cross at 90 degrees does not necessarily mean that they are, unless they have the little square in the corner. All right, well that does it for this lesson. Make sure that you write down these notes here on this page as well as any other notes on any of the other pages that you haven't copied down before.